Hello students, so this is lecture number 3 of the chapter units and measurements. So up till now we have discussed about different types of physical quantities, what are base quantities, what are derived quantities, what are supplementary quantities and about their units. Also we have discussed the conversion of degrees into radians, right? Fine, now in today's lecture we will understand what is dimensional formula, how to represent a dimensional formula, and then we will switch on to dimensional analysis, right? See, we are having 7 fundamental or base quantities, right? Mass, length, time, luminous intensity, temperature, current, as well as amount of substance, right? So this were the 7 physical or base quantities. With the help of these quantities you can derive the formula or you can derive the unit of other various quantities, right? Now when you want to, or whenever you are representing a physical quantity by their symbol, like suppose when mass will be represented by capital M, length by capital L, time by capital T, current capital A, right? So these are the symbols of respective physical quantities, right? So whenever you are representing any physical quantity with their appropriate powers, then that is what is known as dimensional formula for that physical quantity. We will take an example so it will be more clear to you. What I am saying is, whenever you are representing any physical quantity by their appropriate powers of M, L, T, K, A, etc. You are having 7 fundamental quantities, 7 base quantities, right? And these are the symbols of these quantities. So whenever these symbols with appropriate power are represented, then you have written the dimensional formula of that quantity. Let us take one example to make this very clear. Like suppose velocity, right? Velocity, dimensional formula for that, the physical quantity will be written in a square bracket. I want the dimensional formula of this quantity, velocity. What is velocity? A physical quantity, right? What I am doing? I am writing the dimensional formula of this quantity. So now what is velocity? Formula wise, displacement by time, right? What is displacement? I mean, what is the unit of displacement? Meter. What is the unit of time? Second. Clear? Displacement means in a way it represents length, right? So this will be written as length raised to 1 time. What is the symbol of time? T. And the power is 1, right? So this can be written as m raised to 0. Okay, if you don't want to write m raised to 0, that is also okay. L1 t minus 1. L1 t minus 1. What is this? Dimensional formula of the quantity velocity. That means whenever any physical quantity is represented by appropriate power of m, l, t, a, k, etc., then you have written the dimensional formula for that physical quantity, right? And the dimensions of velocities, are 1 minus 1. These are the dimensions of velocity, 1 minus 1. 1 is for length, this is for time. You are getting the point? You just have to represent any physical quantity by their appropriate powers, by taking the help of these 7 fundamental quantities and represent it with the help of an appropriate powers. In short, when any physical quantity is represented by the appropriate power of MLT, you have written the dimensional formula for that physical quantity. We will take another examples, like suppose you don't have to write the units. You are getting the point? Unit is a different thing. Now we are writing the dimensional formula of a physical quantity. Let us take an example of, say, force. Come on, force. I want to find the dimensional formula. I want to write the dimensional formula for this force. So we know what is force. mass into acceleration, right? We'll make use of the 7 fundamental quantities. We'll make the use of 7 fundamental quantities. Fine, no problem. Mass. Still I am writing the formulas. I am not writing the dimension formula. Acceleration, what is acceleration? Change in velocity by time. Mass into, what is change in velocity? Displacement by time. Change in displacement, that means simply displacement by time. Okay. So what is a unit of mass? Kilogram. Or you can write directly, there is no problem. Mass, the power is 1, power is 1, power is 1. So this will be mass. So it will be represented by the symbol m1. Displacement, that represents length, so L raised to 1 upon, change in velocity means displacement by time, and already one time is there, so here it will be time square. Velocity, change in velocity, what is change in velocity? Displacement by time, and already time is there in denominator, so it will be time square. So finally this will be mass into displacement by time square. So time, what is the symbol? T. What is the power? 2. Right? So m1 L1 T minus 2. This is the dimensional formula for the force. 1, 1 minus 2. These are the dimensions of force. 1, 1 minus 2. These are dimensions of the force. This is for mass. This is for length. This is for time. Clear? Clear? Right? Let us solve another example now. See, if you don't want to directly write the dimensional formula, you can first obtain the units. First obtain the unit of a physical quantity, and from that find the dimensional formula. Right? Try to bring the units by taking the help of these 7 physical quantities. That means your unit, the combination of units should be from this 7 physical quantity, from the units of these 7 physical quantities, right? That means let us say kinetic energy. What is kinetic energy? Half mv square. Clear? Suppose we have been said to find the dimensional formula for kinetic energy, right? Okay, no problem. Half is constant and it won't have any dimensions, right? It's not a physical quantity, so we don't have to worry about this constant just now. Okay, fine. So this will be first written as half mass. What is velocity? This is square of the velocity. What is velocity? Displacement by time. So this will be clear, right? Now, as I said, half will not have any dimensions, so I am not including in writing the dimension formula. That does not mean that you can cancel half or you can ignore it. No, just we don't need this half to write the dimensional formula of the kinetic energy, because half is not a physical quantity, it's a constant term. Right? Okay, mass, so it will be m1 bracket. Oh, kinetic energy, this should be written in bracket. Displacement, so that means length by time, the whole square. So this is m1 L2 T2. So this will be m raised to 1 L raised to 2 T raised to minus 2. This is what is the dimensional formula for kinetic energy. That means I am expressing physical quantity by appropriate power of m, L, T, if required K, if required A, etc. So whenever any physical quantity is represented by appropriate power of m, L, T, you written the dimensional formula for that physical quantity. Clear? Let us take another example. There are lots and lots of physical quantities, and you can obtain the dimensional formula for each of these physical quantities. But presently, my advice is don't remember the dimensional formula for each and every physical quantities. That means you will not come across magnetic field, you will not come across magnetic flux, you will not come across surface tension, right? You will not come across thermal conductivity, gravitation constant. These are all the terms which you will learn in 2nd semester or in 12th standard, right? So do not by heart the dimensional formula at present. No, Just understand the concept, how to remove the dimensional formula, and just try to obtain the dimensional formula of the physical quantities which you have already learned. That means you all must be aware about the formula for kinetic energy, formula for force, velocity, acceleration. That is why I have taken those examples, right? If I will say that surface tension means force per unit length, you have not come across this topic, surface tension, then don't remember this, it's okay, right? Only understand those dimensional formulas which we have already studied, the topics, right? Like suppose, what is work done? This must be in your lower class also. Work done is the product of force into displacement, right? Force into displacement, right? See, I will try to obtain this formula till the combination will be from this 7 quantities. That means force. What is force? Mass into acceleration into displacement. Fine. Mass. What is acceleration? Change in velocity by time. Change in velocity by time into displacement. See, mass is included in 7 quantities, yes. Time, yes. Displacement, that means length, of course, but still velocity is not included in this 7 quantities. Still change this formula. What is velocity? Displacement by time, right? So this will be displacement by time. Already one time is there, so it will be time square into displacement. So displacement square. Clear? Velocity is displacement by time. Displacement into displacement, square of displacement. Displacement upon time, and already one time is there, so it will be this. Now you see, finally we have got the format as mass, which is included in 7 quantities. Displacement, that means length, yes. Time, yes. Now write the dimension formula. Mass m, power is 1. Displacement, that is length, power is 2, place 2 upon time, that means capital T square. This should be placed in a square bracket. So it will be m1 L2 T minus 2. Got it? This is the dimension formula for work done. 1, 2 and minus 2 are the dimensions of work done. This is how we will obtain the dimension formula. Clear? You just have to write, or you have to express a physical quantities in an appropriate power of MLT AK if required. Clear? This is how we will remove the dimensional formula. One more quantity we will discuss, and then we will switch on to dimensional analysis. Right? What is dimensional analysis? What are the use of dimensional analysis? Like suppose you have been said to find the dimensional formula for, say, charge. Come on, charge Q. So what is charge? Charge is current into time. Q equals to I into T, current. So it will be A1 time T1. So that is, you can write this M0, L0, A1, T1, or if you are writing A1, T1, that is also okay. So you have written the dimensional formula for the physical quantity charge, right? 0, 0, 1, 1. If you are not placing this, that is okay, because anything raised to 0 itself is 1, right? So A1, T1 is the dimensional formula for the physical quantity charge. Clear? Clear? Few of the quantities which you will practice by yourself, how to write the dimensional formula, like if write the dimensional formula for, come on, I am giving you one formula, G m1 m2 by r square. F is the force, m1 and m2 are the masses, r is the distance. Write dimensional formula for G. Try this by yourself. You have to obtain the dimensional formula for G. And one more, let us say energy is equals to HF. Energy, this is work done we have already solved. F is frequency. Okay, I'll give you the formula for frequency, 1 upon T. Find dimensional formula for Planck's constant. H is known as Planck's constant. You will study about these formulas, don't worry. That is why I have given you the formula, right? So what is, how this equation comes and how this equation is formed, that we'll learn in your 12th standard and 11th standard and 12th standard. There. Okay, so try to obtain the dimensional formula for G and H. Clear? Right? So in the next video, now we'll discuss about dimensional analysis and we'll check whether you got the correct answer for this too or not. Clear?